Hi, welcome to the channel. If you're like most people, including all of our mainstream scientists, you're probably confused by experiments like the double slit experiment. How does gravity work? How can light propagate through empty space? Why is there no gravity in quantum field theory? Right? Quantum mechanics doesn't have gravity, and yet it works, right? Almost like gravity's not needed at the small scales. And yet at the large scales, you don't need quantum mechanics, right? Because gravity seems to work just fine, although there are a lot of issues. And when you try to find the answers to these questions, it all gets super complicated, and it's something you couldn't possibly understand. The point is, nobody can understand this stuff. It is so complicated. The only people that can are the people that basically invented the math, right? But math is a model of reality. It doesn't dictate reality. If you look in the past, behind me, this is the geocentric model of the universe, right? It was made up of many planes of existence, all not interacting with each other. And this is how you were able to account for the motion of the heavens. But the issue was with the planets, right? The planets would retrograde because we were obviously not in this cycle, right? Not a problem for the current model at that time, right? What did they do? They just created epicycles, which is basically add a circle. All you have to do is add another little plane, right? That doesn't interact with that one. The planet was now in its own plane of existence, and that plane of existence did something different. It would actually move differently. This is called an epicycle. And the only way you could understand this system was to have a knowledge, in-depth knowledge of the complicated math, right? And anyone that said, no, that's not the case, because such as Galileo, they were ostracized, made fun of. Galileo was locked up. It's always the case. And this is still the case in today's world. It's still the case. You're still ostracized for outside ideas that challenge the mainstream viewpoint. But what did it come down to? It was a perspective change, a paradigm shift in how we actually looked at the data. Could we come up with an alternate model? Different way to think about it. So your average person couldn't deal with the painful 7 realms of heaven, the complicated math of epicycles, Fourier transforms, etc. But if you have the actual knowledge of the underlying reality, now it's much simpler. We went to a heliocentric model of the universe. Now you don't need epicycles. Why? Because you have a better understanding of the reality. Instead of making reality match your math, now you just changed the math. Why? Because you have a better understanding of the underlying reality. And I think the same thing is going on today, why we haven't had any true breakthroughs in physics since the 30s. The mainstream will not accept alternate views. They won't even look at it. And why? Because they accept completely contradictory, Hippocratic thoughts. They hold opposing views. This is the same people who will accept witness testimony in a court of law, right? And put someone to death based on witness testimony. But now if there's witness testimony that there are aliens here, or that they've been in contact with non-human intelligence, these are the same people, mainstream science, that will not accept any sort of hypothesis even that aliens could possibly be on Earth, or that the phenomenon even exists, despite all that we don't know. So that's why I'm so interested in this, is that I think we need a paradigm shift. And where is a paradigm shift going to come from? Where do revolutions normally come from in scientific thought? Do they come from the mainstream? We've had no change again since the 30s. We still don't believe aliens are here. We still don't believe they exist despite overwhelming evidence, witness testimony. And you can say there's no hard evidence, but chances are the government is taking the hard evidence, or whoever wants to keep this secret, which is probably also the non-human intelligences. In the same vein, we haven't discovered anything new about consciousness. We still don't even have a model of it. Ancient thoughts like astrology, life after death. You had a psychic program in the CIA. The CIA and the US Army literally have, or had at least, probably still have, a remote viewing program. Despite all these things, we still haven't made any breakthroughs at all. And I think it stems back to our base assumptions. So today, I'm going to challenge most likely your base assumption about light, the nature of matter. And I'll do it through 3 parts. The first Hippocratic contradictory belief that our mainstream physicists and mainstream scientists actually hold and think there's nothing wrong with it is they accept that there is a dual nature to light, right? They accept that light can be at the same time a wave and at the same time a particle, right? They just accept this. Why? Because it makes the math work. It gives them an answer, just like your epicycles did in the past. So we'll look at this. And if you stay to the end, may even explain the double slit experiment. The second base assumption that I'm going to challenge, and again, this video will be for open-minded people, is that light speed is not constant. It may be constant in a vacuum, but Einstein said himself, light speed is not constant in a changing gravitational field, or as we'll see clearly, when it goes through a medium. This is why we have refraction. Light speed changes speed. Our modern physics calls it the effective speed of light, right? The effective speed of light through a medium. But light changes speed through a medium. And I'll show you by experiment how that works. And then I'll show you just by observation how we can totally change our minds there and disregard it. And again, accept opposing views. You can't have opposing views. Is light constant, or does light change speed to medium? You can't have both. And finally, the third base assumption that I'm going to challenge today is most likely your assumption that space is empty, that it's nothing, right? That there's nothing in space, despite the idea that light travels through it. Obviously, that would mean that the ether is real, meaning that light actually just propagates through a field as a wave, and that is the ether. And this has been an old idea that is actually coming back lately. I saw Eric Weinstein said on, I believe, the Joe Rogan podcast that, oh, the ether may be real. And the point of this is if you remove these blocking contradictory assumptions, so if you can just suspend those base assumptions for a little bit, you may see that it's quite clear. Actually, you don't need super complicated math. There aren't principles that are impossible for you to understand because you just can't possibly understand all the math and their arguments. Once you remove base assumptions and get to the actual reality, now you can have alternate views that make sense, that make much more sense. And finally, for the guaranteed comments I'm going to get to stay in my lane and not look into these topics, I'd like to say, where do you think this information comes from? Where do revolutionary topics actually come from? They come from the mad scientist in their basement, yes? Well, I actually have a degree in material science from U.S. Air Force Academy, one of the top schools in the nation. Material science is physics and chemistry, so that does kind of apply. And I was admitted to a Portuguese mental hospital, and I'm in my basement. So I pretty much fit the exact bill of a mad scientist in their basement. So where do you think new information comes from? It comes from people like me. So thank you for being here. If you're still here, I think you're in for an exciting ride.
Chris Lato, welcome to Lato Files.
Okay, what you see behind me there is a Ferrocell. It's essentially LED lights around the outside. And inside you have a very thin film in between two plates of glass of ferrofluid, which is tiny nano particles of metal, so magnetic particles. And what he has in here is a magnet. This is from Theoria Apophosis, Ken Wheeler, 9 years ago. And it shows here your actual magnetic field lines, how a magnet is going to bend light essentially through the ferromaterials, but it gives you essentially a 3D image. So an amazing device, recent invention from what I can understand. He'll make the argument here is that everything in the universe is electric. And this is what I've been a proponent of for the past year at least, is that the universe is electric. And I can't believe I hadn't heard of the electric universe theory, actually. It is an alternate view of how the universe works. Everything is electric. the electromagnetic field works down at very super microscopic scales, I believe inside of an atom, which is light, which is an electromagnetic wave, and goes all the way up to large scale gravity. And that is what Ken Wheeler argues here, that the universe actually is electric and you can see it through this device, at least some example of it. So I'll let this part play. I couldn't say it any better than Ken does. Check it out.
The light is actually hitting it and bending it along the lines of centrifugal divergence. The centripetal convergence, where light is literally going like water down a drain, is where you see these black voids in between the white lines. Okay? As you can see, these lines that are moving seemingly clockwise are closest to you. They're brighter. The darker lines is the other side of the magnet. Well, they seem to be moving counterclockwise. Nope, they're moving in the exact same direction, only inverse to your spatial perspective.
Okay, so what that means is you're actually looking into a 3D structure. They're moving in the same direction, right? Above, think of a spiral descending down into the magnet and then going on the other side and coming out the other side in the same direction again. If I have an object and I'm rotating it this direction, right? But now if I look from the other direction, now it will appear to go the opposite, right? So clockwise, I believe, whatever you're seeing. But if you're looking from the other direction, it will appear counterclockwise.
Space has no attributes. Space is nothing. Space is the air inside this donut. The cream filling inside the donut of magnetic divergence is literally the farts, the after effect, the remnant remains of the loss of inertia, which necessitates magnetic divergence and reciprocation. As Faraday called magnetism, he called it the dielectric field. And oddly enough, one of the first experts in electrical engineering was the guy who got closest, even closer than Tesla, to understanding what magnetism was in its relationship to dielectricity, because only dielectricity exists. Only. Magnetism is the loss of that inertia. Electricity is a hybrid of dielectricity and magnetism. That which we call gravity does not exist. Gravity is nothing other than incoherent dielectric acceleration. What you call magnetic attraction and that which is gravity are the exact same damn thing, 100% sure as shit, right as rain, irrefutable, undeniable. Magnetic attraction and gravity are one and the same thing. The only thing that distinguishes them is coherency. In a magnet, we have coherency. In gravity, we have total incoherency. Enough quantity affects quality. Enough quantity affects quality. There's only one field, and there are three field modalities. Electricity and magnetism, and that which we call gravity, they're all the same thing. There is no need for a grand unified field theory. They've always been unified. The only thing that's not unified is human comprehension of the nature of these field modalities in relationship to one another. And they are all one and the same thing. To think of grand unified field theory is as stupid as a moron, a caveman, a troglodyte trying to unify water, steam, and ice. We would roll our eyes. Well, I'm trying to unify water, steam, and ice. Really? They're all one and the same thing. Well, I haven't unified. Well, they're already unified.
Okay, that's just an amazing point, and comes back to what I mentioned in the intro is if quantum mechanics works so well without gravity, and gravity, or at least general relativity, the math, works so well without quantum mechanics, then they don't really need each other, right? It seems like they're already unified. Like Ken Wheeler says here, what's missing is the unification in our brains, in our small, tiny human brains. And I think this is going to change very soon with artificial intelligence. This is going to unify our current physics. And what does that mean by unifying? Is going to get a different perspective, which I believe is already out there, already exists.
It's that simple. Actually, I should have said it's that simplex. It's not simple because human comprehension makes it difficult to explain, making it therefore not simple. But the principle itself, as it stands by itself, all alone, with nobody else trying to figure it out with their caveman brains, it is not simplex. And it's only not simplex because human beings are very stupid. It's not that that it is that difficult to comprehend. It is that we are that stupid. Oh, we've got computers, iMacs, and iPhones. We're so smart. Really? Do you think so? There's one irreducible fact. It's irrefutable. Every branch of science throughout history has always thought that they were right. They always thought they were so advanced. And 100 years later, sometimes 200, we look back on those people and go, oh my God, they were so stupid. Timeless, irrefutable, undeniable. That always happens and always will happen. It's true now as it ever was. It's as true in the future as it ever will be. Thanks for watching.
Okay, I love that part. And it's so true, right? And that's exactly what's been going on for the past 8 decades at least, both with the phenomenon and with the basic understanding of cosmology, the universe, and physics. I think it's about to drastically change with artificial intelligence. And I'm certainly ready for it. It is very, very frustrating. Like you said there, it's much more simple than they make it out to be, right? They'll try and complicate you with math. They complicate the solution with math because you can pretty much do anything you want with math, right? Make it complicated enough. Invent new imaginary numbers. Invent a new system that can make your argument correct. And it's very difficult for other people to understand your manifolds and your Hilbert spaces and all these ridiculous concepts. But at the core, reality is usually much simpler. It's much larger. It's amazingly giant, amazingly small. The numbers are just preposterous, but the underlying principles can be understood. Let's look at the current ridiculousness. Quantum field theory. Watch this. This is so awesome. And I do want to highlight these people are all very intelligent. They're very smart. The problem is there's no self-introspection. They can't imagine that they could possibly be wrong, that their base assumptions could be wrong, that the entire system could be essentially lying to them. And this is why they can't change their view. This has always been the case. So I mentioned at the beginning the epicycles, right? The planes of the universe. That's how they were actually able to explain retrograde motion for hundreds of years, right? They were able to explain it. You just had to learn the complicated math, but it would work. So now if we look at the current standard model and we look at quantum field theory, this is how it actually works, okay? You actually have the same thing as the planes of the heavens, right? This is the neutrino field. Neutrino field, despite there being a dual nature to light, right? A dual nature to light, that light can act as both a particle and a wave. When you look at actual quantum field theory, they've never been able to find an actual particle. They can't find the particles. So what do they use? Quantum field theory is exactly what it sounds like, fields. This was the Higgs field. The Higgs boson was in the Higgs field, right? Which is separated from the neutrino field. And there's an electron field, right? And these don't interact unless there's some miraculous, invisible, virtual particle, etc., that actually acts in between them as a boson. You have the quark field. And the bosons is this other epicycle, if you will, another circle of a Fourier transform that allowed the electron to actually interact with down to the Higgs field. It's exactly like the epicycles of the past. There's no difference. It's exactly the same. And yet they can't see it. They literally can't see it because they're so wrapped up in the math. They have their heads so far up the math that they can't even see that they've lost touch with the reality. And instead they call people like me or people like Halton Arp, astronomer in the 80s. People like Eric Lerner, the Thunderbolts Project, who proposes electric universe. These people are the crackpots. We're the crackpots, right, for promoting an alternate theory, and yet the theory that they're promoting and calling everyone else stupid and not worth the time to even look at, right, to spend billions of your dollars. Billions of dollars have been spent on this, looking for things like dark matter, dark energy, looking for the boson, right, the particle that they're going to find, which is going to prove their standard model. Literally, billions of taxpayer dollars have been spent on this. How much has it been spent on looking into, say, a electric universe theory? How much has been spent on looking into theories that don't assume that the universe is expanding? The answer is zero, very little. Of course, those theories are not developed because no money or time or energy has been spent on them. Instead, they're spent understanding all the epicycles that we currently have going on, such as quantum field theory. And people like Sean Carroll, people like Neil deGrasse Tyson, who have millions and millions of views, right? They're the ones actually pushing the needle. This is why you're so confused. This is why cosmology is always in crisis, is because the underlying assumptions are incorrect. The first one is you can have a dual nature to light, that light is both a wave and a particle. When you actually look down into, when they look down into particle accelerators, what are they actually finding? It's all fields. It's all fields. And they can't interact, right? Just like the epicycles of the past. They can't interact. Why? Because it's an incorrect model. What is most likely the correct model is it's all related. It's all the same. It's all a wave. It's related to electromagnetism. As Ken Wheeler said, the dielectric, right? You either have electric pressure or you have lack of it, which is going to be magnetism. That's it. And coherent magnetism, if you will, is like a laser. And that's what we see clearly as magnetism. And incoherent attraction, this incoherent system, is like gravity. That literally is gravity. And we see this in the cosmos. I'm not going to go into the electric universe theory, but what you see is look at galaxies. Galaxies are spinning. They seem to be at the dielectric, and you have these giant jets shooting out of the poles, essentially, based on most likely magnetism. Everything else is magnetic. The Earth has its own magnetic field. It's basically a giant magnet. The heliosphere of the sun is the actual magnetic relationship, right? They talk about the solar wind being a pressure coming out here and meeting the interstellar wind, right? Because everything's a particle. But what do we find from Voyager 1 and Voyager 2? The heliosphere is actually more circular than we thought, right? Again, doesn't match our models. Why is it more circular? Because it's also where the actual magnetic influence of the sun stops. It's literally looks like an atom, essentially is an atom. If you look, the planets are in close to the dielectric, not exactly with the equator. They're 7 degrees off of the sun. But just like your galaxies, what we see is the universe is electric. What does that mean? Electromagnetic. That is light, implying that everything actually is a wave. That's why your quantum field theory for quantum mechanics works, because everything is a field. It's all a wave. And that's why you don't need gravity at the micro scales, because you're looking at the force. You're looking at it. The force of gravity at the large scales is actually just the electromagnetic force scaled up. And that's why we see crazy things like magnetars, neutron stars. Look at your galaxies. Look at our sun. Look at Jupiter. The scientist who found the aurora, right? He was ostracized. That was just recently, because that could be impossible, right? It's not possible. It's not possible if you have the incorrect assumption, a base assumption. Contradictory, by the way, that light can be something, a wave, and then at the same time can be the opposite thing, can be a particle. Of course you're going to be confused. Everything will be confused. That's why you're confused. And Einstein, I've shown his paper before, 1935. He was promoting a paper in 1935, well after general relativity, well after special relativity, proposing that Maxwell's equations be unified with GUV, basically the shape of spacetime. He proposed that in 1935. So was he a huge proponent of quantum mechanics? No. Same thing as Nikola Tesla. What did Nikola Tesla always say? He thought the whole idea of particles was also ridiculous. He said the universe is electric. Everything is electric. Vibration, energy, frequency. And we even see through E equals mc squared, energy is mass. Everything is electric. There is no dual nature to light. Light is electromagnetic waves. What is matter? Matter is made up of light, which is electromagnetic waves. That's why you won't find a particle. You'll find waves. Particles are just wave energy in a certain formation. Very tight, super dense formation. Okay, so that is part one. First assumption that I'm going to challenge is this contradictory idea in the minds of all of our scientists. You can't have 7 planes of the heavens that don't interact with each other and still describe the actual physical universe. Okay, it's contradictory. You can't have both. You can't really believe that light is a wave and light is a particle. Then surely you will be confused by all these quantum spooky effects. So the next assumption I'm going to challenge is your belief that light speed is constant, that it's constant in all places for all observers. So we'll see how that is not the case through experiment. Thank you for watching. Please hit the like button. It really helps the channel. Consider subscribing. And a special thanks to all my patrons on patreon.com/Chris Lato. This trip to Hestelin could not be possible without them, as well as YouTube members. Thank you so much, and please consider helping the channel. Again, couldn't be possible without your support. For all the arguments these experts make, right, that light speed is always constant, what did Einstein actually say? And this is from ChatGPT, right? If you're not using AI at this point, then prepare to be left behind. So I asked, did Einstein state light is only constant speed and a constant gravitational potential? ChatGPT 4.0 answers yes. Einstein's theory of general relativity allows for light speed to vary depending on gravitational potential. Think about that. Light speed can vary depending on gravitational potential. In a gravitational field, light does not maintain a constant speed in the same way it does in a vacuum. So when we say light speed is constant, it's constant in a vacuum with no changing gravitational field. Does that make sense? Here's how it works. Gravitational potential and light speed. In a region with stronger gravitational potential, closer to a massive object, the effective speed of light, and this is how they square this ridiculous corner in their brains. They call it the effective speed of light, appears to slow down relative to an observer further away from the source of the gravity. So the effective speed of light appears to slow down to an observer further away, right? Because everything is relative. This variation is due to the curvature of space-time rather than light slowing down in the same sense as when it travels through a material. To a local observer near the source of gravity, light still moves at c, but for an observer at a distance, light appears to slow in high gravitational potential regions. And again, this is how they can just believe completely contradictory arguments. Okay, light travels slower in a higher gravitational field. That's why if you bring a clock to sea level, it will actually tick slower than if you bring a clock up to Mount Everest, the top of Mount Everest, or into orbit. Clocks will actually tick faster in orbit. Why? Because there is less gravity. Because there's less gravity. And when you bring that clock back down to Earth, what happens? The clocks are misaligned. This is because light literally travels different speeds, right? It's all relative. But since everything is relative, that means light travels different speeds. I don't know how else to explain this. Like, it's proven by experiment. The problem is space-time, right? That's why you're confused, because space-time is warped by matter, right? This is your physical assumption. Cover this in a third assumption. Space-time is actually not a thing. That's why you're confused. That's why you're confused by it, because it's not real. It's a model that actually outlines how the universe works, how the universe interacts. but it is not a real thing itself, right? It's just describing the actual medium of the universe, which is not nothing, by the way. Also, how light speed changes. Let's look. Number 2, gravitational redshift. I've mentioned this a lot in my other videos. When light climbs out of a gravitational potential, its frequency and wavelength change. Again, this is a measured effect. We've actually experimentally measured this, unlike dark matter, dark energy, and any of those things. A phenomenon called gravitational redshift. This change in energy affects how we measure its speed across different gravitational potentials, contributing to the appearance of a varying speed over long distances in a gravitational field. To the appearance, right? Although it does. It's not just an appearance. When we measure the clocks at sea level, and then we experimentally measure the speed of the clocks, which is the speed of light, right? How fast light is traveling back and forth is how we measure time. When we measure those in different gravitational fields, you get a different number, okay? You can say however you want. It appears, or that's an effective speed of light, but that's why you're confused. It's not appearing, it is. It's not effective, it is. It's a different speed. Number 3, constant speed and uniform gravitational potential. So yes, this is what Einstein said, is yes, you will have a constant speed of light in a uniform gravitational potential, otherwise known as a geodesic. In the absence of gravity, or in a region of uniform gravitational potential, right? Is there any place where there's no gravity? Light would indeed maintain a constant speed c. This aligns with the special relativity postulate that light speed is constant in a vacuum for all observers in an inertial, non-accelerated frame of reference. So what does that mean? A geodesic. This would explain why things orbit. How can you orbit forever with no friction? How does that make any sense? You can orbit forever with no friction because light is essentially traveling the exact same speed, right? It's not bending in any direction along a geodesic where your gravitational field is the same. That's why. And since I put in base assumption 1, there is no dual nature of light. Light is an electromagnetic wave. Light makes up matter, so matter is an electromagnetic wave. This means that when you have something in orbit, it's on a consistent gravitational potential. It's not going to bend. It's not affected by light bending, which, as we saw in first assumption, as Ken Wheeler showed, is basically explains gravity, right? Is your electromagnetic attractions. So in summary, Einstein's theories imply that light speed is only truly constant in a region where gravitational potential is also constant. Again, that's around geodesics, right? Same place on the surface of the Earth. And we can measure this with clocks, right? I don't need any new experiments. We have all the information we need. We will find the answer. It's coming with artificial intelligence. At some point, the mainstream will not be able to just gloss this over to make up contradictory beliefs, telling us to believe one thing and at the same time, the opposing thing. It's just stupid. As Ken Wheeler said, it is stupidity. In varying gravitational potentials, the observed speed can change due to, and again, mainstream argument, space-time curvature. But now try and describe space-time to me. What is space? How does space-time curve? We'll look at that in section 3. Okay, but as promised to show you that light speed actually changes, I gave one example, right, which should be obvious, is the time clocks. That should be obvious. Okay, but let's look at another example of how light speed changes through different mediums, and you see it every day. This is from one of my favorite YouTube channels, at the Action Lab, and he actually gets to the right answer through experiment and then talks himself out of it due to, again, theoretical physicists theoretically making up a bunch of shit that doesn't make any sense. And I'll show you here through 2 amazing videos. So this will explain it. Love this.
I have 2 arrows here face the same direction, but not really. They're actually facing the opposite direction. Now, I've been told that refraction happens because light moves slower in water than in air. So it's like a tank driving that suddenly hits some mud at an angle. This causes it to turn into the slower moving mud a little bit. Now this explanation makes sense, but did you hear what I said? The speed of light slows down in water. The most famous constant in the universe, the speed of light, named after the speed of light, slows down. Now that's what I've been told my whole life, but I'm not going to take their word for it anymore. I'm going to actually try to measure it.
Okay, and he does. You're going to watch his brain break, okay, as he actually talks himself out of what's actually happening. And he's going to accept two contradictory things, right? He's going to say in this video, does light travel the speed of light or does it travel slower? And you know what he's going to say? He's going to say both. He's going to say both. Only after he does the experiment and listens to 3 blue, 1 brown, right? Another theoretical physicist who theoretically can make anything up and change his mind. Check it out.
It's always the same using a technology called time-of-flight LiDAR. On the back of an iPhone, there's an array of infrared lasers right here. You can't see these infrared lights with your eyes, but the camera sensor can pick up some infrared light, so you can see it blinking here. In fact, if I just use a night vision camera, then you can see the laser array shining from my phone. The phone can actually use these infrared lasers to measure how far away something is. It sends out a short pulse in the nanosecond range of light, and then measures how long it takes to see the reflection of that light. Now, since light moves really fast, that reflection happens very fast. The phone can actually measure that slight delay in time. So to get the distance, you just take the time delay times the speed of light constant divided by 2, since it has to go there and back. Now, you can download apps that can show you the distance of things in front of the camera using LiDAR. But the key here is that the distance that the app is outputting is based on the fact that the speed of light is constant. If the speed of light changes, then the distance will be incorrect. So let's see if the distance changes if the light has to pass through a different material. So right now I'm going to focus this Action Lab sticker here. Then I'll take this acrylic block and move it in front of the camera. So it's still focused on the sticker and the infrared lasers are going right through the acrylic block. But notice how the distance changed. So it actually changes from 17 centimeters to 20 centimeters. Now, even if you thought it was just because we're putting something in front of it, that still doesn't make sense because this is actually a shorter distance, so the distance should decrease. So we know it actually is measuring below to the sticker. The only thing that could mean is if the light was actually traveling slower through this acrylic block. Now, this change wasn't that significant, so let's try to make it more significant by using a much longer block of acrylic. I'll use the wall of my vacuum chamber here. I can still focus on the sticker shining through the whole length of the acrylic. First, when I just focus the sticker through the air, it gives me about 54.2 centimeters. But now when I do it through the acrylic, it gives me about 82 centimeters. That's a huge difference. So it would seem that the speed of light has actually slowed down significantly. In fact, I can calculate how much it has slowed down using the incorrect distance. The new speed of light is just the true distance divided by the incorrect distance times the actual speed of light. So if I just take 54.2 divided by 82, then I get the speed of light through the acrylic is only 66% of the actual speed of light. And I can verify this by looking up the refractive index of acrylic, which is 1.5.
So that should just blow your mind right there. Okay, you can see it through experiment. You can do this at home on your own. You can clearly see that the speed of light changes, right? It slows down, just like I mentioned on those clocks. When you have different gravitational potentials, in this case, the speed of light, or as they say it, the effective speed of light appears to slow down. It actually does. And that's measured through refractive index. And refractive index is different for each material. And they found it through measurement, right? Through observation. That's how light bends. That's why you actually see underwater looks quite strange, right? If you're looking at something, it's not exactly where you think it is. It's because light travels a different speed underwater. And you can measure this, right? They measured it. You saw right there, he measured it. And that's where we get the refractive index. And this is from my favorite named law, which is Snell's law. Really the law of refraction. So this is a formula used to describe the relationship between the angles of its incidence and refraction when referring to light or other waves, right? Other waves passing through a boundary between two different isotropic media. So different media that have different refraction indexes. So it's actually a simple law, right? This is your incoming light wave. You have your interface, and now your outgoing light wave changes immediately, right? At the border, where they talked about that tank tread. And it's simple, right? The sine of this angle over the sine of this angle is equal to the velocity of light in this medium over the velocity of light in this medium. That's it. Velocity 1, velocity 2, right, is related directly to those angles. That's it. What's also cool is the law follows from Fermat's principle of least time, which in turn follows the propagation of light as waves. Fermat's principle is also cool, right? If there's someone drowning in the ocean, for instance, and you're a lifeguard, how are you going to get there? Imagine this is someone drowning and this is the lifeguard stand, okay? The lifeguard's not going to run straight to that point, right? They're not going to minimize distance over the water either, right? I'm not going to run as far as I can here to this point and then swim this way. A lifeguard's going to minimize your time, right? Minimize the time. And that just so happens to align with this formula, right? You're going to run here based on the velocity that you can run. And then from that point, based on the velocity in the second medium, like in water, now you're going to swim. And it actually minimizes time. So least amount of time. That's how light and I guess every other wave works. Okay, and Action Lab, again, amazing YouTuber, does things through experiment. Watch as he talks himself out of this, right? Based on, we're going to look, some theoretical mumbo jumbo math numbers that light doesn't actually change speed. The effective speed is not true. And somehow it can be both light speed and at the same time, not light speed, traveling slower. You watch, there's this dichotomy in his brain. And again, that's why we're all confused, is because everyone's confused because your underlying assumptions are incorrect.
Electromagnetic waves are moving at the speed of light, but the combined wave peaks are actually propagating slower than the speed of light. The wave appears to be moving slower when it's moving through the material. But really, all of the electromagnetic waves are moving at the speed of light. But the combined wave peaks are actually propagating slower than the speed of light. So does light ever slow down? Well, no, and yes. The fundamental propagations of the electromagnetic waves always move at the true speed of light. But the end result that we can actually measure in a real transparent material is that the electromagnetic wave peaks are slower. Now, if you're interested in this and want more detail, I recommend watching 3 Blue 1 Brown's video on this. He does an amazing job at explaining and visualizing this effect that I'm talking about.
Yes, and I watched the whole video and I'll show you parts of it here. He does an amazing job of talking around the problem, using math to confuse you, and then disregarding the actual true reality. As he just said right there, does light travel faster or slower in a medium? He says the opposite things. What is the answer? Does it travel slower or does it travel at light speed? He says both, yes and no. Again, you can't have a dichotomy. You can't. You can accept inaccuracies, right, in order to move on with your model, in order to progress in some manner, but ultimately you have an incorrect understanding of the actual fundamentals. That's why we're all confused. That's why we're going to continue to be confused, and they're never going to find things like dark matter. They're never going to find dark energy. You're never going to find gravity at the quantum scale. You're never going to find quantum effects at the scale of gravity. Why? Because your underlying assumptions are incorrect. So let's look at what 3 Blue 1 Brown argues. Links to these full videos are in the description if you want to check it out. I'll just summarize is basically, why does a prism separate light out into different colors? This is quite a good argument. And what he says is that light is always traveling at the same speed, but you have these little oscillators, right? Inside each of the atoms of the material is oscillating, and this will actually combine with the light wave and make it appear, right, through constructive and destructive interference, it appears like the light is traveling slower. But in actuality, all that's happened is you have a phase shift. And phase shift is real. You do have phase shift in materials. But I'll show he's missing one very large key point. So just watch a few seconds here.
If the frequency of the light, omega sub L, is something much smaller than the resonant frequency. For this particular simulation, it takes a little bit of a moment before things get into their full swing. Eventually, it finds a nice sinusoidal motion, but the amplitude of that motion is much more modest in comparison. So what our equation is telling us is that the larger the difference between those frequencies, then the bigger the denominator, so the smaller the overall wiggle to that charge. And again, this is something you can see in the footage with my niece. As I'm applying a force with a frequency that's very different from what the swing wants to do, she ends up oscillating at the same frequency as my force, but she's going at a relatively low amplitude. Stepping back, what this means is that as you shine light into a material, like glass, it's not just that it induces wiggles in the charges of that material, but the specific size of those wiggles depends on the frequency of the light as a consequence of this denominator term. And the more those wiggle, the bigger the size of this second order wave caused by that layer, which in turn causes a bigger shift to the phase of the overall wave. Because a lot of different shifts to the phase are what causes this apparent slowdown to the light, it means that the amount that it will slow down ultimately depends on the frequency of the light. So that is the real reason why prisms work. You cannot truly explain the light separation until you get down to the driven harmonic oscillator.
Okay, so he has amazing animations. Seems like a nice guy in a sweater with his niece. This video has 1.4 million views, by the way. And this is how he explains that light is actually going slower, but not really slower, right? Yes and no, it is going light speed, but it's also appearing to go slower. So at the same time, it is going slower. And again, it's all, the dichotomy is just ridiculous. The hypocrisy is unbelievable that they can just hold these thoughts in their brains, right? What he's explaining here is phase shift. And yes, the light is interacting with the wave particles of the medium, right? And it does affect the phase shift. And it does matter the frequency of the light, right? But what he leaves out here is, where is the start of the wavefront? Where is the beginning of the wavefront? Okay, all of his examples, if you through this whole video, right? His whole video, look, this is how he describes the light wave. But where's the front? Where is the front? The wave front. I was a fighter pilot for 18 years, and for, I think, 4 of those years, I was an electronic attack expert. And what we care about is the actual initial wavefront. Okay, when you actually paint an aircraft, it's when the first wave hits the aircraft, right? That wavefront will actually hit the aircraft. And if you have enough detail broken out, you can actually identify the type of aircraft by which parts of the wave will come back first. That's the wave front. That is extremely, extremely important. Is where does the wave hit? Okay, it's not constant. We're not in a constant wave field. There's a wave front. When that first very beginning of the wave, right? The front of the wave. When we talk about speed of things, right? It's who gets there first, right? Who touches the wall first wins in the Olympics. You're not talking about the swimmers as they're constantly swimming, right? And the waves will make one of them go slower, one faster as they're going. No, it's who gets to the wall first. Where is the wavefront? And he completely leaves that out. He leaves it out. And this video has 1.4 million views. And one of the smarter people I know on YouTube who literally did through experiment showed that wavefront is slower, believes this argument, right? And believes that this makes sense. This makes sense. But it doesn't make sense, okay? Because what will actually happen is the front of the wave will be here. The wave front has effectively slowed down, meaning light has slowed. The light is slowed. Now, why does it matter the frequency? Is because, yes, look how many times it will interact with the actual electrons in the medium. much more. You're going to, as it's cycling through at a faster frequency, it will interact more with the medium, with those electrons, like he explained correctly. The light will interact with the medium, the electrons of the medium, and this will react more. So it will slow down more. Why? Because it's interacting with the medium more times. I don't need complicated math, right? Down here, it's interacting with the medium less. Okay, there's actual less motion. So it will diffract or refract less. It will bend less. It will slow down less, right? It'll go faster. But this is what they do, right? They make up complicated answers. We're going to use math and solve the problem. No, you're not going to use math. You're going to use math to confuse the problem, to confuse it. The wavefront travels slower. It's not confusing. Okay, it's confusing if you accept incorrect, complicated, opposing assumptions, right? You accept opposing assumptions. The light wave, the front of the light wave, travels slower as it goes through here. Then it travels faster to the second medium based on Snell's law from hundreds of years ago. And it bounces back the front of the wave, right? The front, not the wave shift going on in the middle. As 3 blue, 1 brown explains somehow in his brain, it makes sense. The wave front will come back and will travel slower. And this is a wave front, right? The front of the wave. Okay, that is what's actually traveling slower. If we look here, the waves are more spread out. This is Huygens principle, right? Explained by the tank turn. And how does this actually work? Is he argues or argued that it's actually light is a spectrum of circles, essentially a spectrum of circles here that will create the wavefront. Okay, so you're actually creating the wavefront, and this will go into the double slit experiment. Said we'd explain a double slit experiment. If you get to the end of part 3, I think you will understand it. This is your wavefront. Okay, this is what travels slower, and it's measured. We just saw how it's measured. Okay, there's not light somehow out here. That's 3 blue, 1 brown. Ridiculously tries to explain it. Okay, there's not light out here, and then we effectively see the speed of light here because your math makes that work. No, this is where your wavefront is. And this is the advantage, I think, of being a fighter pilot, right? I saw firsthand, it doesn't matter what you think. It doesn't matter what your theoretical idea or tactics will do theoretically, right? Because that doesn't really matter. What matters is the reality. It doesn't matter if you pray and really believe that your God is going to defend you, and then we drop a bomb on your head. Okay, that invalidated your idea, right? That God will defend you because you have the right beliefs. No, the bomb blew up. Same thing happened in Iraq. The Iraqis had GPS jammers, right? Theoretically, just like our theoretical physicists, our theoretical scientists, the GPS jammers theoretically should have prevented your GPS bombs from blowing up. But what did we do? We dropped GPS guided bombs onto their GPS jammers. So it doesn't matter what your theoretical stuff is. When you measure, right? You measured the light. Action Lab measured this. He measured this. And then because the math says that light speed travels constant speed, right? And because 3 blue, 1 brown looked into it and decided that he solved the case using complicated math, difficult to understand, Weiss phase alignment, etc., they can just talk themselves out of it, right? This is the world that we currently live in. But this is Huygens' principle. And that states that every point on a wavefront is itself the source of spherical wavelets, meaning light is a spherical expansion. It's a wave in 3D space. Okay, and this will go to the double slit experiment. Is where is that wave, right? The wave of light is actually in a circle, right? It's in a sphere. What we see is wave fronts when they combine. So the sum of these spherical wavelets forms a new wavefront. You can get emanating from different points that mutually interfere. And the secondary wavelets emanating from different points mutually interfere. So they mutually interfere constructively and destructively, and this is how we get an actual wave front. So the sum of these spherical wavelets forms a new wavefront. As such, the Huygens-Fresnel principle is a method of analysis applied to problems of luminous wave propagation. both in the far field limit and the near field diffraction, as well as reflection. So explains refraction and reflection. And that'll be important for part 3 of this series. As you can see right there, through our rules and laws of refraction that have been in place for 100 plus years, and then you can actually see it with experiments that you guys can do at home. Right? You can do this at home. All you need is an iPhone and some sort of glass, and now you can see for yourself that the speed of light changes throughout a medium. And there's other examples of this, right? Just as in the past, they had obvious examples that the Earth wasn't the center of the universe, right? There were many different ways you should be able to see this. Like, you don't even need to do home experiments, right? They've already been done. It's not general relativity says that orbiting clocks should tick about 45 millionths of a second faster than they would on Earth, okay? General relativity doesn't say that. General relativity doesn't say that, but that's what our physics understands, okay? General relativity is a model, okay? It's just a model of what really happens. And what really happens that orbiting clocks do tick slower, all right? About 38 microseconds per day slower on Earth than they do in orbit. That's what really happens. It's not general relativity says that, okay? We're shown, as Action Lab says, he says that the speed of light is constant according to general relativity. It's not general relativity says something. It doesn't change the math. I saw this firsthand in the military. Remember back, I was a young scheduler in Korea. We got a new JDAM. I mentioned that. We got the chance to actually drop an inert. There was no explosives in it, but to practice dropping a real GPS-guided weapon. Right? I think they're $20,000 each. A very exciting opportunity for our squadron. I was setting it up as a scheduler. So I had to set up the mission. We want to put the bombs on these aircraft on this day for this mission, right? What did I get back from the maintainer? The maintainer said, sorry, sir, we don't have that in our computer system. We can't load the bombs because the computer system doesn't have the bombs as an option, right? Basically, the math, the computer math, doesn't allow us to drop the bombs. And I asked, well, do you have the bombs there? Yes, sir. And is there anything stopping you physically from putting them on the aircraft? No, sir. So the only issue is your computer says that you can't put it on. Yes, sir. We can't do it. Okay, hung up. I called the senior chief, right, person who runs the whole show, talked with them and explained that, look, the math, the computers don't control reality. Okay, the reality is we have the bombs. You can put them on the plane and we will go drop them, which is what we ended up doing. Reality defines the math, the computer system. Okay, you go, the bomb's there, yes. Okay, we put it into the computer system. It's not the reverse. It's not that the math drives reality. And that's where we ended up now. This is straight off Google. Okay, physics Libre text. This is what all of our physicists believe. This is their underlying assumptions. General relativity says that they should tick slower. So that's what happens. No, that's not what happens. The reality is light speed travels slower in a higher gravitational field. That's it. It travels faster when there's less gravitation, as in a vacuum of space. And where's the vacuum of space? Where there's no matter, less gravity. This is the second assumption that I'm challenging, hopefully. If you can just remove the limiting belief that light speed is constant and go and really look at the data, it's obvious. It's obvious. I didn't have to show you any complicated math. I didn't have to show you any wavefront, radian, cosine technologies. Didn't have to explain any theoretical things, right? You can show through experiment light speed travels slower, and you can find it in many other examples. So easily found. What's limiting is our human biases that can somehow accept at the same time opposing views, right? Why? Because it works. The same thing has always worked in the past. Epicycles worked. The humans of the past, which are basically genetically identical to us for all intents and purposes, they believed wholeheartedly, locked people up in prison, probably killed them, probably did terrible things, right? In the name of science, right? Science, which is supposed to be open-minded, which you see today is absolutely not open-minded. Why? Because underlying assumptions. Hope you enjoyed part 2 of this series. In part 3, I'll actually show how refraction can be related to the cosmos and explain another alternate view. Again, just another perspective that can simplify all of our understanding and remove all this confusion, right? Because there is a lot of confusion. Why? Because you're assuming opposite things. You're assuming the wrong assumptions, obviously. Thank you for watching. Please hit the like button. It really helps the channel. Consider subscribing. And a special thanks to all my patrons on patreon.com/Chris Lato. This trip could not be possible without them, as well as YouTube members. Thank you so much. And please consider helping the channel. Again, couldn't be possible without your support. This is part 3 of a series challenging, hopefully, your assumptions, at least the mainstream view of physics assumptions on our world, about our universe. And the first assumption was actually that light has a dual nature, that it can be both a wave and a particle at the same time. If you look at this experiment right behind me, these are linear polarizers. You see there, no light goes through, right? We're seeing 0 light coming through, right? Because linearly polarized. But now, if we add a third linear polarizer, right? Nothing happens here, right? It's still light blocked. Nothing happens there, still light blocked. But if you put in the middle, look, now we can see through. We can actually see. Go there, it goes away. Rotate it back, goes away. But at 45 degrees now, it actually lets more light in. They're able to explain this again with super complicated math and also assuming that light is an electromagnetic wave. How can it also be a particle? Again, underlying incorrect assumptions. How do they explain this, right? That somehow it can change. As we see a 45-degree oscillator here, it can change the light to somehow allow some through, right? This is how they explain it. Spooky quantum effects, they say. Spooky quantum effects. Again, if anything's not understandable, just make the math harder, put in the word quantum, and add a few free parameters, and everything will work out, right? Add another epicycle. Add a neutron field. We'll add a polarization field. We'll add some other field. How does it make sense in my brain? Is through Huygens principle. I think light is actually made up of small spherelets, basically propagating in a sphere, right? That's actually how light propagates in our universe, right? And will travel different speeds in different mediums. I showed that in part 2. Part 1 is there's no dual nature of light. There are no particles. Particles are just still waves, as explained by quantum field theory, right? They're still all fields. There are no particles when they look down in smallest scales. In Huygens principle, if you look, even the wavefront is made up of circles, right? That's why we have a double slit experiment that looks like this, because it's actually a wave that propagates out from spheres. So I think that's actually how it explains this, along with the double slit experiment. In this video, part 3 of the 3-part series, challenging your assumptions. The assumption I want to challenge today is probably your belief that space is empty, right? Is the lack of stuff, even though there are electromagnetic waves traveling through it, right? Light is obviously traveling through space, which is nothing. How do they describe this now? Is that we made up photons, right? We said photons is something different. It's actually a wave and a particle, right? A photon somehow is massless, like a wave. But when photons interact with matter, now they have momentum somehow, right? Even though momentum is mv, mass times velocity. Somehow photons have 0 in the mass column, but are able to impart momentum. Again, we have dichotomies. A opposing views. How can you have a massless particle that imparts momentum? Momentum is based on mass. Everything in our physics is based on mass. So again, we have contradictory beliefs. You have completely contradictory belief that mass imparts momentum, and yet we have a massless particle, which is the basis of pretty much all of our physics is based on light at different scales. So of course we're going to be confused. Of course you're not going to understand current modern physics because it doesn't make any sense. No one understands it. You have your reality, and then you have a complicated, super in-depth, many times invented, made up math model. And they rely on that math model to dictate what reality is when it needs to go the other direction. Math is just a model of reality. You can't have underlying contradictory assumptions or you will be confused. And how do they fix this? They fix this through epicycles. Yes, just add another layer. So let's look at what light is. Light is electromagnetic radiation that can be perceived by the human eye. Visible light spans the visible spectrum and is usually defined as having wavelengths in the range of 400 to 700 nanometers, corresponding to frequencies of 750 to 420 terahertz. In physics, the term light may refer more broadly to electromagnetic radiation of any wavelength, whether visible or not. In this sense, gamma rays, X-rays, microwaves, and radio waves are also light. The primary properties of light are intensity, propagation direction, frequency or wavelength spectrum, and polarization. Its speed in a vacuum, 299,792, 458 meters per second, is one of the fundamental constants of nature. And here's where it gets weird. Like all types of electromagnetic radiation, visible light propagates by massless elementary particles called photons that represent the quanta of electromagnetic field and can be analyzed as both waves and particles. The study of light, known as optics, is an important research area in modern physics, so can be analyzed as both waves and particles. That does not mean that they are both. And this is what they say: visible light propagates by massless elementary particles called photons. Again, your base assumptions are incorrect. In part 1, we looked at, can light be both a wave and a particle at the same time? And the answer is no. There's nothing to be found. They have never found a particle, right? No one's actually seen an atom. Our best guess right now, and it's terrible, is quantum field theory. And what do you find is the Higgs boson is an excitation of the Higgs field. Again, a field. They can't find any particles. There are no actual base particles. It's like dark matter, dark energy. We're never going to find it. Why? Because it's a misunderstanding. We're never going to find a particle, just like we're never going to find dark matter or dark energy, because they are misconceptions in our understanding of reality, right? The math works. So that's why you can analyze it as a particle and you can analyze it as a wave, but it doesn't mean light is both. It means you can analyze it that way. So this dual nature of light, the problem is if space is empty, right? If there's nothing there, then how can waves propagate through nothing, right? How do they propagate through nothing? Space, we went up there and we found in the 60s that it is empty, right? Empty mostly of matter, although there are random protons, etc., spaced out. So there is actual matter in space, but for the most part, it's empty of matter. How does light propagate through empty matter? We're like fish in the ocean, right? We can't understand what this water is. It's like humans back in the past. Well, like I can see through the air, so what is this invisible air hitting me? What's this wind coming from? So how does light propagate through space? If space-time is empty, it can't. That's why you have to invent photons. You have to invent particles. Because what can travel through nothing, supposedly, is matter, right? You could throw a rock up into space, and that's how it can propagate, right? Is you actually traveling through nothing, which is another just amazing concept, okay? Zero does not exist. Zero doesn't exist. It exists as an idea. There's an idea that you don't have something of something, right? But all it is lack of actual existence, which you can't have, right? Nothing doesn't exist. Nothing doesn't exist. You can't point to nothing. You can't. Where is it? There is no nothing. Nothing doesn't exist. It's like zero. And all of our math doesn't work. Why? Because you're trying to divide something by zero. Why? You're dividing by an idea that doesn't really exist. Zero is a math model to describe an absence of existence. But there is no absence of existence. There is no nothing. You can't have nothing. This is why the whole idea of space being empty, for one thing, doesn't make any sense. This is why we're confused. The answer is simple. Okay, how can light propagate through space? Because light, like everything else, is an electromagnetic wave. Light is an electromagnetic wave. It's propagating through a medium, and it will change speed based on the medium it's propagating through. And when it's propagating through space, it will propagate close to the full speed of light, right? Unless it's in a gravitational well. If it's in a different gravitational potential, then it will travel at a different speed. Einstein said this. It's not general relativity says that light speed is constant. Okay, the math is misunderstood as light speed is constant. But if you look at the actual reality, like I showed in section 2 of this video series, light does change speed. It does change speed in a medium based on refraction. So if you haven't checked out that video, please check it out. It really explains light speed is not constant, and that's how light can bend. Okay, light changes speed in different gravitational potentials, in different mediums. When you shine light through glass, it will travel out the end. It will exit the end, the front of the wavefront. Okay, the actual light at the wavefront, which is how I would describe speed of light, will change speed through a medium. So if you actually clock when it enters and when it leaves, that time will be less through water than it is through air. And that's why we have refraction. That's why light bends. And that's why I'm going to show today you can also use refraction to explain gravitational lensing. So today I'll propose and show you an alternate theory that does explain gravitational lensing through refraction, meaning there is an ether. Spacetime is just a model that explains how light interacts with the ether, and there is no nothing of space. Okay, that's why you're confused. That's why we're all confused. How can light propagate through nothing? We can make up all these complicated things, say it acts like a photon, it's an actual particle. So then how is it propagating through space? Well, it can act as both a wave and a particle. Okay, that goes back to I'm confused. Why? Because it's dumb. The whole underlying assumption is ridiculous. And yet I'm the crackpot, right? People like me are the crackpots, and yet they believe obviously opposing things at the same time. So in this case, what is gravitational lensing? A gravitational lens is matter, such as a cluster of galaxies or a point particle that bends light from a distant source as it travels toward an observer, kind of like what a lens does. The amount of gravitational lensing is described by Albert Einstein's general theory of relativity. Okay, and I'll show you how we can derive that using refraction. If light is treated as corpuscles, right, which is again ridiculous, traveling at the speed of light, Newtonian physics also predicts the bending of light, but only half of that predicted by general relativity. Okay, and it's because it doesn't take into account time dilation, right, which is a relativistic effect. Then you have Albert Einstein's general theory of relativity, and how did he get the real answer? And this actually proved in 1919 around the sun. Basically, he was able to accurately predict the deflection angle of light, gravitational lensing around the sun. using general relativity. But they still treat it as a particle, right? But instead of a corpuscle now, what you have is a photon, right? And a photon has 0 mass. So it's not really a particle, is it? And yet it imparts a momentum. So again, acts like a particle in that case, but flies through empty space as a wave particle. Like, it doesn't make any sense. There's a reason we're all confused. There's a reason you can't describe space-time, right? So explain space-time to me. Define space-time. In fact, define space. How does light go through it? Why don't we see particles flying around in space everywhere, right? Like little flying cars going around. Because it's not. It's an electromagnetic wave. Okay, and this is gravitational lensing around the sun, right? It's during an eclipse, 1919. It's one of Eddington's photographs. And this is really what broke general relativity, right? Einstein was able to describe the correct amount of bending of the background image. And this is a well-known effect, right? Gravitational lensing. How do they describe it now? The matter will bend space-time, and then space-time tells the light how to bend. That doesn't make sense, right? That's their argument, is that matter bends space-time, and then space-time tells matter how to bend, right? But because they separate matter and light. If I say it that way, it obviously doesn't make any sense, but this is literally their argument. That's their argument. Okay, space-time is not a thing. You can't find space-time. Space-time is a model for how light actually works in reality. How you can model actual light. This is a famous Einstein cross, right? So there's a background image and it's bent, lensed, if you will, just like through a lens. And so the question is, could it be just like a lens? And the answer is yes, it can be just like a lens. But you have to have a medium. That's why they won't consider it. This is it again. If we look at gravitational lensing, man, it sure looks like a lens, doesn't it? Again, gravitational lensing, you see it here. It honestly looks like it's bending, right? Like a lens. But they say it's just space-time. That's how space-time is bending, right? This is the argument. Space-time bends and creates this gravitational lens. I wonder if that's the case. If so, then it is surprisingly exactly similar to refraction. Okay, I went over this in part 2 of this series. Okay, what is refraction? Based off Snell's law, it's the interface between two media of different refractive indexes. So N1 and N2 are refractive index. Since the velocity is lower in the medium, okay, so this is the velocity, and refraction works not just for light, it works with any wave, okay? What happens is you have the wave, the speed of the wave front, okay, not the phase, the speed of the wave front in medium number 1, and you have related to the speed of the wave in medium number 2, okay? And if we look at light, what will happen is the velocity of light will slow down in a denser medium. The velocity of light actually slows down. And I showed this again in part 2. If you still believe that light is constant, you can measure it through experiment. That's your velocity, and this is defined by Snell's law, okay? And they found this experimentally. They didn't find this through theoretical physics, thanks to Snell. And it's a simple formula. Again, I don't need complex math to prove any of these ideas, okay? The sine of this angle over the sine of this angle is equal to the velocity in this medium compared to over the velocity in medium 2. That's it. Simple formula. Okay, so now I'll show you how we can use that same refractive index. What is really causing that refraction is a change in the speed of the wave through the medium. It's not just light, okay? Any wave in any medium can be explained by these formulas. So if we just apply that to light in an actual medium, such as the ether, and apply the refraction principle to gravitational lensing, it can accurately predict what we see, right? That's it. Applying refraction to gravitational lensing. So here it is. All right, title, Reinterpreting Gravitational Lensing as Refraction a test against observational data. So the abstract, we present a novel hypothesis interpreting gravitational lensing as a refractive effect rather than exclusively a consequence of space-time curvature in general relativity. First, it says novel hypothesis here. I had not heard of it, okay, until basically came up with this idea or considered it and then found that, yes, the math does work. But this has been already brought up, that gravitational lensing can be described by laws of refraction. Found out about electric universe, found out about Halton, ARP, Ken Wheeler, Eric Lerner is also out there. I've seen much of his work, as well as Unzicker. I think you do have people out there now with YouTube. We're finding this information now. They can't keep it. The gatekeepers are losing control, right? And very soon we're going to have real answers. All right, back to this. In this model, light bending occurs due to refraction as photons traverse regions of varying gravitational potentials. And by photon here, we're talking about light, electromagnetic waves, effectively experiencing a change in their propagation medium. So really, due to refraction, the photons will traverse regions of varying gravitational potential. And as I showed in the other parts, Einstein said himself, and GR doesn't deny this, right? General relativity is that light travels different speeds in different gravitational potentials. You can see this through experiment, and you can also see it just by noting that clocks will travel slower on the surface of Earth compared to the top of Mount Everest. Okay, this is a measurable effect. Why? Because light travels different speeds in different mediums. We derive a refractive index-based formula for gravitational lensing and test this model against observed lensing data, including the Bullet cluster and Abell 1689. These are both well-known gravitational lensing areas. Preliminary results show that the refractive model approximates observed deflection angles in galaxy clusters, offering a potential alternative or complement to dark matter in explaining mass discrepancies. Let's see if it can do it. So, introduction. Gravitational lensing, traditionally explained by general relativity, results in light deflection when passing near massive objects due to space-time curvature, is what they say. Observed lensing phenomena in galaxy clusters, such as the Bullet cluster, suggest mass discrepancies between baryonic and lensing inferred masses, typically attributed to dark matter. Again, doesn't exactly match our theories, so what are we going to do? We're going to add something made up. We're in the dark ages of physics right now. This paper proposes an alternative hypothesis that gravitational lensing is a refractive effect. This hypothesis builds on the idea that light speed varies in a gravitational field. This is not an idea, okay? This is a proven fact, causing a refractive bending, analogous to light passing through a medium of variable density. So that is the argument, right? Can it be tested in matched observations? We derive a theoretical framework for gravitational lensing as refraction and test it against observational data to assess its alignment with known gravitational lensing measurements. All right, here we go. Hypothesis and model derivation. Our hypothesis proposes that gravitational lensing arises from a refractive index effect. Within this framework, the refractive index n in a gravitational potential is derived based on the idea that light's velocity effectively changes due to the gravitational field. And this is just, again, simple logic. Effectively, a lens in space works the exact same as a lens on Earth through glass because it's affecting the medium, the gravitational potential, deriving the gravitational refractive index. So light speed and a gravitational potential. This comes from time dilation. So the speed of light, c effective, in a gravitational potential, phi, is given by c effective equals c times the square root of 1 minus 2 phi over c squared. Okay, so this is a proven, or at least shown to be accurate through general relativity formula. So we just use the same formula. Okay, for small potentials, phi is much less than c squared, so this can be approximated as c effective, so the effective speed of light is equal to speed of light in a vacuum, c, times 1 minus the gravitational potential of where it's going through over c squared. So the refractive index n is defined as the ratio of the speed of light in a vacuum, c, to the effective speed of light, c effective. Okay, so that's it. We're just saying this is the ratio, which is how you define refractive index, right? It's the speed of light in one medium over the speed of light in the other medium will provide the refractive index. This refractive index n varies with gravitational potential, implying that light bends as it traverses regions of differing n values, much like it would in a medium with a varying refractive index. And that's all I'm saying. I'm saying that we don't make up space-time and say that it's nothing. Okay, we just assume that it's a medium. So we take a different assumption. We assume that there is an ether, that the medium of space is not empty. Okay, it's actually something that light can propagate through. It's a medium of propagation for light. So now we calculate the deflection angle using refraction. So the deflection angle theta of a light ray passing near a massive object can be derived using the concept of refraction across a varying refractive index. According to the hypothesis, the gravitational potential causes a gradient in the refractive index. So a change. What will happen? Light will slow, bending the path of light, similar to Snell's law in optics. I already showed Snell's law. It's my favorite law. Gradient of refractive index. The gravitational field creates a spatial gradient in the refractive index, delta n, causing light to bend. For a gravitational potential phi generated by a mass m at distance r, what you get is delta n, so the gradient of refractive index, is equal to the change in gravitational potential over c squared. That's it, right? Change in the medium over c squared. So change in gravitational potential is gm over r squared. So you get your refractive index is now gm over c squared r squared. Now, if we can do the deflection angle formula by integrating the change in angle over the path of the light ray as it approaches and exits the mass m, we find the total deflection angle. So theta refraction, your total angle, is going to be equal to the integral. So because you have many wavefronts, right? Remember showing that wavefront is made up of many spherical particles. You have the change in n, derivative, is roughly equal to 2 gm over c squared r. This formula for theta refraction matches the standard gravitational lensing angle from general relativity, suggesting that light bending in a gravitational field can indeed be modeled as refraction. Look at that. Predicting the lensing mass. So the hypothesis implies that the deflection angle is directly proportional to the baryonic mass. Okay, not dark matter. We don't need dark matter if gravitational lensing is purely refractive. Therefore, mass discrepancies observed through traditional gravitational lensing analysis might be explained by a reevaluation of the refractive properties in the gravitational field rather than requiring unseen dark matter. Meaning we don't have to make up new shit that's invisible, that we can't find after many decades of looking for it. Okay, we can simply assume that maybe our models are incorrect. Maybe our base assumptions are incorrect. Have we tried to look at the ether as a medium? Has anyone done any actual money-backed science? The answer is no, it's not. The gatekeepers will not let you even talk about it. We're called crackpots. People like me, disenfranchised. People like Eric Lerner, disenfranchised, laughed at, mocked. Usually in the past, that's exactly what happens. All the people with the new ideas against mainstream paradigm were called crackpots. They were mocked. This is just as recent as the Aurora Borealis. Guy who came up with the Aurora, mocked. Told he was a moron, right? Can't be correct. What happens? Yes, it is based on solar wind. Guess what? Electromagnetic interactions with the sun. Surprise. All right, and then part 3, testing the refractive lensing model with observational data. To evaluate this hypothesis, we compare the refractive model's predicted deflection angles with observed gravitational lensing data for well-studied galaxy clusters. We use gravitational lensing data from the Bullet cluster, known for its strong evidence of mass discrepancy inferred from gravitational lensing, and Abell 1689, a massive galaxy cluster with extensive lensing arcs and high magnification, used as a benchmark for lensing studies. So known observational parameters, Bullet cluster, the mass, observed deflection angles from observations, and the radius. There's the data for Abell as well. And now calculations for the predicted deflection angles. Bullet cluster using the refractive model is going to come out to basically what is predicted by general relativity, right? 1.91 times 10 to the minus 5th radians. This matches the observed deflection angle for the bullet cluster, indicating the refractive model could adequately explain the observed lensing without requiring additional dark matter. Similarly, for a Bell 1689, again, the same formula showed you how it was derived. This result also aligns with the observed deflection angle for a Bell 1689, supporting the hypothesis that lensing could be explained through refraction. And from the derivation, if I remember this too, okay, the reason Einstein was able to show that it's double the deflection angle is because as it bends, it takes longer to go around. It's actually traveling slower, as we saw there through gravitational time dilation. That's where the 2 comes from, is you have to take into account the time delay as well, because it travels slower over a further distance. So discussion, the refractive lensing model, according to ChatGPT, data analyst provides a new perspective on gravitational lensing by attributing light bending to changing in the refractive index due to gravitational potential. In both the bullet cluster and a Bell 1689, the predicted deflection angles closely match observed values without invoking dark matter, right? So you don't need dark matter. It bends enough. You can just look at what's actually there. We don't need to make up any new ridiculous invisible stuff. However, the refractive model requires further validation across a larger sample of galaxy clusters and gravitational lensing phenomena. It also raises questions about potential observational signatures unique to refractive lensing, such as different bending behaviors in regions of varying mass density. Conclusion. The study proposes that gravitational lensing might be fundamentally refractive, challenging the dark matter paradigm and really space-time as empty and nothing, right? Because now I'm saying that there is a medium. By redefining gravitational lensing as a refractive effect, we provide a model that matches observed lensing angles in galaxy clusters without requiring dark matter. Further tests are necessary to explore the broader applicability of this model and its implications for cosmology. Okay, is this the end-all, be-all? Obviously not. Okay, it is more complicated than that alone. If light is as I propose it is, then you will have other dispersion effects, right? But in this case, you can show that we can model gravitational lensing through refraction. And why do astronomy and the physics community not want to even look at this possibility? Because it heavily implies that space is not empty, right? It's not nothing. There's not nothing in space. That makes zero sense. Nothing is a human math idea. You can't divide by 0. Why does it create singularities in all your math? Because 0 doesn't actually exist, does it? It's a lack of existence. How can you have a lack of existence? How can you have a wave that propagates through nothing? How can matter tell space-time how to curve, and then that curvature tells matter how to bend? Like, how does that make any sense? How can light be both a wave and a particle? It doesn't make any sense. That's why none of our predictions are lining up. That's why JWST is finding incredible galaxies way past what we would assume would be the beginning of the universe. You're looking at now, they're finding mature galaxies, so spiral galaxies in 290 million years after the alleged Big Bang. How can we have structures in the universe of galaxies that are over 5 billion years across? According to our current model, nothing can be over 1 billion miles across because it hasn't had time to float out to those locations. Okay, and I said at the beginning of this 3-part series that by the end, you should understand the double slit experiment and why it causes so much confusion, if you will. And now you should understand that there is no particle duality. One of the main arguments is that it is a wave. Light is a wave. Everything actually is a wave. Particles are made up of waves. So there's no particle-wave duality. What you have is waves that are organized into the shape of particles that can be analyzed as particles, but there is no duality. Light is not both. You can't have both. You can't eat your cake and have it too. It's one or the other. So how is it described here? As the splitter. Okay, what is this actually a single photon or whatever electron that's splitting into two? Or is it just the same thing along the same wave front, if you think about it? traveling in a circle. So when we actually go to detect something, when you're trying to decide which slit it went through, which direction did it go, when you're actually trying to decide that, and all of a sudden, oh, you know what? It always goes the other direction. Or it comes out looking like a particle. Well, what happens when you measure something is you are interfering with it. You're observing it. And what happens when you're observing? What happens when light touches other light in certain formations, right? When matter touches light, it will interfere with the wave. It will affect the wave. That's the measurement problem. When you observe something, anything, you have to touch it, right? How else do you observe it? You are touching the wave or some portion of the wave, right? Every object gives off black body radiation, full spectrum. Every object internally. That means always giving off radiation. Gravity has no distance limit. Waves propagate in a sphere, propagates in a sphere. So what you're actually doing is this will affect this. It'll affect it. Why? Because the wave, that is the wave. If I touch it over here, it's going to affect the wave over here, won't it? It'll cycle down just to 1. If I touch the wave over here, it could collapse. Collapse. Because what happens? You are affecting the wave when you observe it with any detector. Detectors made out of what? Light waves in dense configurations. Now, if I go to observe what is happening, if I go to detect it, I'm actually interfering. I'm touching that light wave. You're interfering with the system. And how do you get an interference pattern, right? If you just send one particle, one electron through here, if I shoot one electron particle, right, I'll get an interference pattern, meaning that electron particle will interfere with itself. Very confusing, right? If you believe contradictory things, contradictory base assumptions. But if you believe everything's just a wave, you're not really shooting one electron. Okay, you're shooting a wave. You are shooting a wave densely packed in one specific area as an electron. Okay, but once it gets to these locations, what will happen? It will go back to what it is normally. It's a wave. You will affect the wave. That's it. If you just remove the base assumption, which is contradictory, that light can be two things at once. Light can have its cake and eat it too. If you just remove that assumption and consider, just pretend that light is only an electromagnetic wave, that matter is made up of light, which is only an electromagnetic wave, then you see that everything is waves and the double slit experiment makes sense. That's it. It's not confusing. We don't need extremely complicated, ununderstandable quantum mechanics math to accurately predict something, right? We can remove a base assumption and you can think about it, and using our primitive human brains, we can actually, just like we have in the past, break the cycle of these ridiculous base assumptions pushed on us from the mainstream, right? I thought the same thing you were probably thinking 4 years ago before I went on this, I don't know, crusade, if you will. Okay, I thought the same thing. I believed mainstream. Same thing I believe mainstream about aliens. They think they know everything. Of course there can't be aliens here. Nothing can travel faster than the speed of light. Space is empty. You can't manipulate these things. Okay, well, if space is not empty, if space is a medium and everything actually is just an electromagnetic wave, then if we can learn to manipulate electromagnetic waves, maybe we can travel faster than light. Maybe we can zoom around the universe. And maybe this information has, on purpose, been kept from us, kept from human civilization until it's ready to accept it. And I think this is actually what the phenomenon has done, has really kept us in the dark until we're ready. Like a seed. A seed will not expand until all the conditions are correct in its environment. I think the environment was not correct. Hopefully it is now, will be in the near future, because AI is going to explain this to us very quickly. And you're going to have many people like Neil deGrasse Tyson, Sean Carroll, all these people that called all the other alternative theories ridiculous, called them crackpots, while at the exact same time believing the stupidest shit imaginable, they are going to look like morons, just like it has always happened in the past. It's like these people just don't read history books. Just go and read a simple history book. Look what happened to Galileo, Leonardo da Vinci, Nikola Tesla. All these people were completely ostracized, right? Even Einstein did not believe that space-time was the ultimate, right? Einstein died on his deathbed scribbling formulas. He had a theory in 1935, a paper, the Rosen-Einstein paper, which mainstream disregards that he was trying to unify GR, general relativity, with Maxwell's equations, right? Basically calling everything essentially a wave, or at least unifying those two things. They disregard that and they say, oh, it's a wormhole. That's the wormhole paper. Yeah, if you read the title of it, sure sounds like he wasn't 100% sure of his own theories. And if you listen to his own words, again, light is only constant in a constant gravitational field, which means a geodesic. That's how you can have orbits, right? How can you have a frictionless orbit? Makes no sense unless you consider removing the base assumptions that I talked about in this series. So I hope you enjoyed this series. I hope it gave you some new insights. For me, it really clears up a lot of the confusion. Okay, there's an amazing amount of confusion, and I think it does deeply relate to the UAP's issue, the phenomenon, how we can believe contradictory things. We can trust witnesses in a court of law, put people away in jail for things that they've seen and experienced, and yet when they talk about, through no benefit of to themselves, alien visitation, non-human intelligences, crazy experiences that they've had. I mean, if you were kidnapped by aliens, they put implants in you and stuck random things up your butt, I'm sure you wouldn't want to tell anyone else, right? These people are not saying it because they want to, right? They're saying it because it happened and these experiences happen. So I think it is related, and I think we're going to get some serious breakthroughs with artificial intelligence in the very near future. And that's why I'm not freaking out anymore. I'm not breaking guitars, etc., to try and get this information out, because I know it's going to come. Unless it doesn't. Unless it doesn't. It's been 80 years. Okay, if you like that, then definitely check out my interview with Dr. Alexander Unzicker. He's a doctor of physics doctor, and we talk a lot of these concepts, such as the ether and why modern physics still believes in particles, although we haven't found one, and a lot of the same crossovers with UAPs. We also talk about scalar waves and how scalar weapons could be possible. Also check out my interview with Dr. Branco. He was a neurologist, and we talk about the nature of consciousness, also related. I also have playlists related to this stuff. Couldn't do it without my patrons. Thank you so much, as well as YouTube members. And thank you for watching. Hit the like button. Peace.